So let us now take a deeper look at the various auction forms. And actually, even though we have described these four different types of auctions as things which are, it seem very different, if we actually investigate it a bit more closely, we'll see that there are some apparent similarities, right? So let's first start noticing the similarity between the ascending bid and the second price auctions. So in the ascending bid auction, remember that basically bids start out at lower value, and then we keep on increasing the bid till only one player is remaining, right? So let's imagine how this would play out. For example, if we had three bidders, each of whom had the value of 10, 20, and 30 respectively, right? So you've got three bidders. One bidder has a actual value for the good as 10, the second one has 20, and the third one has 30, right? So imagine that you start out with a bid of 5. At this point, all three want to actually get the item, right? So then somebody would be willing to pay a price higher than 5, right? So suppose you raise the price to 6, again, all three will be willing to pay. Once you raise the price above 10, though, the second highest bidder is going to drop out, right? But you still have two people who will be willing to pay that price, right? So you can keep on increasing the price. Now, once you reach 20, then you have got basically the second bidder being indifferent between going or not. And if you raise the price just above 20, at that point, two bidders drop out. And basically the person who had the highest bid is going to get the object. But notice that this person has to pay a price just above the second highest bid, right? Or in fact, if the amount by which we were raising the bids was in terms of any real number, then it would have been paying a price which is very, very close to what was the second highest bid. Now, notice that this is actually going to be very similar then in that case to the second price auction, right? So we'll see a result in the second price auction, which will show us that in case of second price auction with independent private values, then it is actually dominant for the bidders to bid their own true value, right? In which case, again, if you had 10, 20, and 30, that would mean that the person who had bid, who actually has the highest bid, which is 30, right, would get the item for a price which is equal to the second highest bid, which is 20, right? So you can see the similarity there. Now, the same similarity also holds between descending bid auctions and first price auctions, right? So in descending bid auctions, remember that we start off with a very high price and then keep going down till somebody actually is willing to pay the price, right? So imagine that you are starting out at a price which is more than 40 in our example of 10, 20, and 30 valuation, right? So at 40, nobody is willing to bid, obviously, nobody, because the highest possible valuation here is 30. But once you start decreasing the price, is it the case that once you reach 30, immediately the person may actually end up bidding? Well, maybe, maybe not, right? So what are the trade-offs? So if you still go below, right, the person might still think that, okay, that person can afford to wait and see and then pick a price which is lower than 30. Because then that person has to pay a lower price, right, for the item, right? So then there's a trade-off in thinking about, okay, how far can you wait till another person potentially can come in and grab the object? And so you want to bid just above that price, right? Interestingly, we'll see that the same actually results hold true in first price auctions, right? Where we'll see that the optimal strategy might not be to bid your own actual valuation for the good, but to bid a value which is lower than your actual valuation, right? So all of this kind of leads to kind of the two fundamental questions that come up when we are thinking about how to design auctions, right? So one question from the buyer's perspective is to think about how should the buyers bid in the different auctions, right? So this is an item which is very important from the buyer's perspective, but is also important from the auction designer's perspective, because the auction designer has to take into account, given an auction structure, how would the buyers be expected to behave, right? And that leads to the general question, what is the optimal auction design more generally, right? And we'll think a bit more about what do we mean optimal. So optimal from whose perspective, and what is this person trying to maximize or minimize, right? So this will come up. So before we get into all of these things, let's take a deeper look into the second price auctions, right? So these are also the Vickrey auctions as we discussed. So the main central result is the following, which is with independent private values, bidding one's true value is a dominant strategy in a second price sealed bid auction, right? So this is the main result that we are going to showcase. And the dominant strategy here that is being used, this is in the game theoretic sense that you have studied before, right? Okay, so let's frame this auction as a game theoretic problem. So who are the players? So you have the different bidders as the players, right? And how are the bidders basically identified? So each of the bidders has some true value for the object. So bidder I has a value Vi, and this information is private to the bidder, right? So none of the other bidders know what this valuation is, right? Of the different bidders apart from their own valuation. And this is something that even the seller does not know, right? Okay, so this is the setting. Now, whenever we are describing a game, we have to discuss players, strategy, and payoff, right? So what are the different strategies of these different bidders? So each of the bidders has to decide based on his or her own value of the item Vi, what is the amount Bi to bid for the item, right? So here we are allowing for the possibility that a person may be willing to bid an amount which is different from one's true valuation of the good, right? So it's not necessarily the case that Bi will be equal to Vi, but we'll show that in equilibrium, there is actually a dominant strategy to actually have Bi equal to Vi, right? But that is a result, right? That is not an assumption. Okay. So what is the strategy for each player? It's to decide Bi, which is how much to bid as a function of whatever the true value Vi is of the bidder I. Okay. What about the payoff? So the payoff depends on whether the bid is the winning bid or not, right? So if the bid Bi is not a winning bid, right, then the player does not get the item, and therefore the payoff to the player I is 0. However, if Bi is the winning bid, right, then the player gets the item, right, and has to pay a price Bj, which is the second highest bid, right? And then the payoff to the player I is given by Vi minus Bj, right? So notice Vi is the valuation of player I for the item, right? And Bj is the second highest bid for this item, right? So that is how you get. So we also, in order to complete the description of the game, we also need to talk about what happens if you have got ties. That's not going to play an important role here. And there are a variety of assumptions that you could have made, all of which are more or less equivalent. So one assumption that you could have made is that if you have ties, then there's a equally likely chance that the people who have bid the highest is going to get the item, right? The other assumption that you can make is, for example, start out by first ordering the set of players. And then if among that set of players, if you have some fraction who are actually bidding the same amount, and which is the highest amount, then the item will go to the one with the lowest index in that set of players, right? So you can drive different assumptions. They are all kind of like similar for our regard, right? Okay. So what is the claim now? Now that we have discussed the game a bit more formally, the claim is the following, that in a sealed bid second price auction, it is a dominant strategy for each bidder Bi to bid Bi equal to Vi, right? So a dominant strategy means doesn't matter what everybody else is doing, their best strategy is to actually bid their true valuation. This is what this result is saying, right? So in order to show this result, what you need to show is that you can consider any deviation from this bid, right? And you can show that in none of the deviations is the payoff is going to be higher compared to bidding the true value, right? And again, this is regardless of whatever strategy everyone else is using, right? So how do you prove this? You have to basically consider two cases, right? So the two possible ways in which the player could have deviated, right? So either the player could have bid a higher bid compared to the true valuation, so bid value Bi which is more than Vi, or you could have a case where you have got the player bidding a lower value, right? So you are bidding Bi less than Vi. So these are the two possible cases that we need to consider. Now, the key point in trying to establish this result is the following kind of insight, right? Now, the value of the player's bid is only going to affect whether the player wins or loses, but never affects how much the player is paying in the event that she wins, right? Why is this the case? So again, if you go back to the payoff, notice that either the payoff is going to be 0 or the payoff is going to be Vi minus Bj, right? So in 0 or Vi minus Bj, there is no Bi, right? So which is, remember, the actual bid of player I. So Bi does not figure here, right? So then where does Bi make the difference? So Bi makes the difference in deciding whether the player is going to win the item or not, right? But it does not make a difference in terms of the payoff that is going to the player, conditional on him winning or not, right? So this is the key thing, key insight that is going to be there, right? So then what is the amount that the player has to pay? Either this player pays 0 if he does not win the object, or if he wins the object, he's paying a price equal to Bj, which is the second highest bid, right? So since all the other bids are remaining the same, remember, we are looking at I alone. I'm kind of like deciding deviate, other players are remaining and doing the same thing, then a change in bid is only going to affect the payoff if it changes her win or loss outcome, right? So let's now illustrate what is going on. So imagine that for player I, the true bid would have been to bid BI equal to VI, right? Now we are considering different deviations. So one deviation to consider is what happens if a player actually ends up bidding a higher value, right? So you can have different cases, right? So imagine that this was also originally the highest bid, right? So that the second highest bid was something which was below this BI equal to VI, right? So some value which was lower than this. Now, in this case, if the player bids a higher amount, then nothing changes, right? The player was earlier also getting the item. The player is still getting the item now, right? And the player is in fact paying the same price, which was equal to the second highest bid, which was below VI, right? So by bidding a bit higher, it did not affect things, right? The only way in which it can affect things is that if the highest bid apart from this player was actually above this VI, right? In this case, it would affect things in the sense that it might change the probability that this person is actually winning the object, right? So from not winning the object, perhaps you end up winning the object. But if that is the case, and now the bid is higher than the second highest bid, then the player will see is going to end up with a negative payoff, right? Which is worse than the zero payoff that it was getting before, right? So this suggests that, if you are bidding higher, that is not going to actually help you, right? So raising the bid will only affect the outcome if the second highest bid was actually above the new raised outcome and the true valuation of the player. In this case, if player I actually ends up winning, then player I will end up paying more than the valuation of this good, right? So which will be a negative payoff thing. Okay, what about the other way? Suppose you decide to kind of like bid lower than your actual valuation for the item, right? Now, if among the other players' bids, the highest possible bid was already above your actual valuation, then anyway, you were not getting the item before, and by bidding lower, you are still not going to get the item. So your payoff remains the same. The only way in which the outcome kind of like changes is that if you actually had the second highest bid in between what you actually was your true valuation and what you have bid now, right? But this can only lead to kind of like an inferior outcome for you, right? Because now you end up from actually winning the item to not winning the item, right? So the lowering up of the bid is going to affect the outcome. Only the highest other bid, which says BK, was in between. And in that case, I is going to lose when earlier it was possible to win with non-negative payoff, right? So in any case that you can consider, you cannot actually do strictly better off, right? Either you will be in the same payoff as you had when you had bid your value truthfully, right? BI equal to VI, or you are going to end up with a situation where you are going to actually end up with a negative payoff, right? Which was worse than before, right? So these are the two cases. So if we can kind of like actually, do this more formally as well. So suppose that instead of bidding your true value, which was VI, bidder I chooses to bid a higher value, BI prime greater than VI. So as we discussed, this is only going to affect the player I's payoff if I were to lose with bid VI, but would win with bid BI prime, right? But if that is the case, if this second bullet point is actually happening, then what this means is that this highest other bid among all the other players, let's call that BJ, must be between BI and BI prime, right? Between what the player was initially bidding versus what the player is now bidding BI prime, right? So in this case, what's going to be the payoff? So the payoff from deviating is going to be equal to at most VI minus BJ, right? Which is actually a number less than equal to 0, right? And so therefore, this deviation to a higher bid does not improve actually I's payoff, okay? You can again consider the other case as well. Suppose you decide to, instead of bidding VI, you are going to deviate by bidding a lower value, BI double prime. Again, this will only affect I's payoff if earlier I was winning with a bid VI, but now is going to lose with a bid BI double prime, right? So if before deviating VI was the winning bid and the second place bid BK was between VI and BI double prime, then in that case, earlier the player had a positive payoff, but now is getting basically a 0 payoff, right? So again, kind of like deviating does not improve the payoff, right? So this is basically the strategy in case this kind of reasoning is new to you, I encourage you to actually place some numbers in place of VI. So imagine you put in, suppose my bid is 80, and you can think of other possible scenarios of what the other players have their bids. And then you can actually try and play around with this and see that under the rules of the auction, of the second price auction, you can never do better off than by actually revealing your truthful valuation, right? So that's why this kind of auctions are considered very popular, in the sense that, here, even though the rules are complicated, your best strategy that you can adopt is to actually bid what you actually truly value the item for, right? So that's why this is considered a very nice form of auction, right? So to summarize, truthful bidding is a dominant strategy, which means that this is the best thing to do regardless of whatever the other players are doing, right? And interestingly here, it does not matter if the other players are basically overbidding compared to what their true value is, underbidding compared to true value is, the other players are colluding or not, if the other number of other players are changing, right? Or if they're doing something completely irrational or unpredictable, all of these things do not matter. The result is that, it is always optimal to bid your own true value, right? So that's the beauty of the result, right? And interestingly, this is true even if the other players are not optimally behaving, right? So they may be behaving in a very suboptimal way. Still, the result is that, you should be bidding good, right? So whenever you've got this dominant strategy equilibrium, this kind of like powerful results are hold. And these are very nice in the sense that then in that case, you don't have to actually form beliefs about what the other players are doing, right? So these are results which said that independent of what you think the others are doing, you only have to focus on what you know about yourself, right? And you have to just actually bid your own true valuation. And that will be the optimal thing, in the sense that you cannot deviate and do better off in any state of the world, right? So that's the strength of this kind of like dominant strategy equilibrium